Hello and welcome to grade 12 class of mathematics. Today we are starting chapter 1, which is covering sequences as well as series. So inside sequences we have what we call arithmetic sequences and geometric sequences. And then inside series we have finite arithmetic and then finite geometric series as well as infinite series. And then we are going to start in this video by looking at sequences. An arithmetic sequence has two types also inside, which is linear arithmetic and quadratic arithmetic. Ask yourself, what is an arithmetic sequence? They say here, an arithmetic sequence is a sequence where consecutive terms, which means terms following each other, are calculated by adding a constant value, either positive or negative, to the previous term. We call this constant value the common difference. Take note of that. It's what we are going to be referring to on the rest of the chapter. Let's look at this example. We have 0 minus 3, 6 minus 9, and so on. It's a sequence, right? So we don't know where it ends. This takes position 1, position 2, position 3, position 4, position 5. We call this position terms. And that means 3 is our term 1, term 2, and so on. Okay, so how do we find the common difference? We take the current term minus the previous term, minus 9 minus 6 is equal to minus 3. Minus 6 minus 3, which gives us minus 3. So you don't have to show this minus, you can do it in your hand and just write the common difference. That's what we are interested in. And then you go on and minus 3 minus 0 is minus 3. 0 minus 3 is minus 3, right? There is your common difference, and you see minus 3 between each terms, which means you are adding minus 3 from the first to the second, and so on. So what you want now to say, our common difference is equal to minus 3. Then there you have it. Common difference is minus 3. I hope you got that. Let's say you wanted the next term, T6. You would say T6 is equal to minus 9 minus 3. Then you would get to minus 12. That is all well and good, but what happens now if you want term number 50, term number 100, whatever random term you want? You should be able to get it, and you can't just be adding minus 3 until you get to 100. We don't have time for that. So that brings us to our next part in the arithmetic sequences, which is getting the general term. How is the general term derived? It says, we know that T1 is our first term and we call it A. And then to get the second term, you took that term, T1, and then you added the difference, which gave you term 1 plus the difference. Okay, to get T3, you take 2, and then you add the difference, and so on and so on. Okay, this is the derivation of how it's done, but ultimate goal is for you to know this formula. So this formula says, if you want term number whatever, which is the nth, okay, term we don't know, whatever position, is equal to A, the first term of the sequence that is given, and then we add whatever position minus 1, and then we times by difference. So Tn is your nth term. A is your first term of the sequence. And say whatever term minus 1 times the difference. So in this case, our first term was 3 and our difference was minus 3. From our sequence, let's say you want the 10th term. So we would say T10 is equal to A. What was our A? 3 plus position 10 minus 1 to make term 9 or so T, and then T10 would be equal to 3 plus, and then we know T is minus 3, so multiply by that, then we have 9 times 3, and then T10 is equal to 24. So generally, you can say the general term Tn is equal to A plus n minus 1 times d. A we know 3, and then we say plus. N we don't know because it's general. Then d we know it's minus 3. Then we can take 3 to the front, minus 3 into n minus 1 equal to, you see that Tn is equal to 3. You can open the bracket and simplify, positive 3. That and that is 6 minus 3n Tn. Does this ring a bell? This is an equation of a straight line, mx plus c. This is that, and that is your y-intercept, which is c. Which means an arithmetic sequence, also called a linear arithmetic sequence. So you can use this name to refer to the arithmetic. Is also called a linear arithmetic, which means if it's a linear graph, we can be able to plot it. You see that? So let's go and say that is our equation, and that will be your y, and that will be your c, and this is your mx. If you rewrite that, you get n is equal to minus 3 n plus 6. So because we have the first 5 terms, we can say we have the first 5 positions. So your coordinates will look like Tn, which is position 1. When you put 1 for x, you are getting 3 out. If you put 2 there, you are getting 0 for y. That's your x and y. You are getting minus 3 for 3, and so on. Which means you can plot this on your axis. So for the point at 1 and 3, you have a point there. Positive 2x and 0, you have a point. Ooh. You have a point there, exactly on the line. And then you have minus positive 3 and minus, which I don't have, somewhere there. And then you have a point about here. Then if you join those lines, you get a straight line graph. moving on, we have what we call the arithmetic mean, which is defined as the number halfway between two numbers. So what it says, you would have, for example, n, that unknown number, and then you have 17. So to find this number, you have that is between two numbers, you would say it is just an average of the two numbers. So you would say 7 plus 17 divide by 2, because you have two numbers and then we want what is between them. So this is the arithmetic mean. 24 divided by 2, which is equal to 12. So this number that we didn't know is 12. And when you further dissect this should give you an arithmetic, which is 17 minus 12 gives you 5. 12 minus 7 gives you 5. So the arithmetic mean should, when put in this sequence, give you a common difference, right? Which makes this now an arithmetic sequence. So in summary, we have an arithmetic sequence has a common difference D. These are the things that you should be taking from this section. An arithmetic graph is a straight line that whenever you are asked to plot, just know, expect a straight line, okay? D is the gradient because we have a straight line graph, right? D is the gradient because we have a straight line. The general formula, this is very important. You will apply it because you can be given a sequence to find the nth term, or you can be given the formula to find the sequence. It can go either way, so be able to use the formula, understand it, know it by heart, and you will be good. And next we are going to look at geometric sequences. You stay tuned for that. Practice this. And if you have any questions, put a comment below, and remember to subscribe, like, so that you never miss a video.